Hey guys, what's up? Welcome back. Let's move on to particle emitters. So when it comes to particle emitters, this is a omni emitter. What you can see happening is that it emits particles omnidirectionally. So that's pretty easy. You have a directional emitter, which will emit particles based on a direction that you tell it. Right now, it's x1, y0, and z0. That means that its vector is just heading in that direction. Then you have volume cube, which is a volume emitter, and it emits particles within the volume. And there's some settings that are making them be pushed out from the volume. Then you have a volume sphere, and then you have a volume cylinder. So a volume sphere is the same thing, but it'll emit particles from a spherical volume. A volume cylinder will emit particles from a cylindrical volume, and a volume cone will emit particles from a cone, and a torus will emit particles from that torus. But the main difference between this guy and this guy is that these are based on a volume. Alright, so that's something to keep in mind. There's a couple of extra ones that I will talk about once I get to them, which are the surface omni, or the surface emitters, and the curve emitters. Those are sort of like more specific, a little bit more specialized. They're pretty handy though. So start with the simplest one, which is actually the directional. The directional emitter is the simplest emitter of all, because it doesn't have that many attributes to deal with. So if I select this emitter right there, open up the attributes, you'll see that it has a speed, which if that speed is increased, just go back, stop, and press play. Playback speed every frame. So if that speed is less, then they don't move as fast. And of course, if that speed is higher, then they move really fast. Right? There's a randomness to the speed. So speed random of, let's say, 1. Then no, that's too much. Yeah, well, that makes sense though. They have a speed of 1 and a random of 1, so that of 0.1 and a random of 1. That means that some particles are going to go 1.1 with a speed of 1.1, and some particles are going to go with a speed of negative 0.9. So that's something to keep in mind there. So the randomness, theoretically shouldn't be higher than the actual speed. That way they're all heading in the same direction. It's just that some are moving faster and some are not. There's a spread value, so I can make them spread out like so. And there is this rate. So the less the rate, the less particles, the more rate, the more particles. Now you're not constrained to 0 to 500. You can type in a number. You can do 9,000 particles, for example. So that's a lot of particles, and that's per second. So that means my playback right now is 30 frames per second. That means that the particles are going to go, they're going to have 9,000 particles within 30 frames. If I do 1, then there's going to be 1 particle every 30 frames. And as you can see, their speed is changing, or it's randomized because of that random value that I gave those particles, or the emitter. That's pretty much that. You can have other things happen, but that's just keeping it simple. There's a minimum and maximum distance, so let's just make the speed for a second 0 and the spread 0. So right now it's emitting particles. Oh, there's a randomness still, so there we go. But they're all at its origin, so we're not really seeing them. If I were to increase the minimum distance to say 1 unit and the maximum distance to be 2 units, then it'll start emitting within that range that I told it. So from 1 unit to 2 units. and it's emitting, of course, one particle every second. But if I increase that, then it's going to do a lot of particles within that range. So I hope that kind of makes sense. Now that I'm thinking about it, you can do pretty cool effects there. If I were to change the direction. Right now, the direction of this is based on a vector. Alright, so it's 1, 0, and 0. That means that on X they're heading that direction. On Y they're in 0, and on Z they're in 0. But if I were to increase the direction Y to 1, then they're gonna go 45 degrees. And if I change the direction X to 0, then they're gonna go up, like so. So I'm just gonna show you something really quick here. If I take this, say from 0 to 50, if we were to animate these values, direction x1 set key and direction y0 set key, and at frame 50 direction y1, then that value is animated, so it's sort of like doing a little swipe there. Isn't that neat? And of course that is the amount of particles that it's doing. Alrighty, so that is that emitter. Let's just hide this. Let's move into the Omni. Pretty much the same principles. There's a couple of different values here, but they're pretty much the same. You also have the rate, you also have the minimum and the maximum distance. You also have the speed and the speed random. So yeah, it's exactly the same. But with this guy, if you think about it, if you change the speed back to 0, and you change the minimum distance to, let's say, 1, and the maximum distance to 1.1, then it's emitting particles, 500 particles, within that range. So if I increase this range a little bit more, like that, it's making sort of like a little sphere of particles. And all of them are not in, maybe I need to make it a little bit thicker. See how it gets thicker on the edges? Inside there's no particles. All these particles are just resting within that range that I told it to. Keep in mind that you can always say solver's initial state set for selected. And once you do that, you can even tell the emitter to not emit any more particles. So now those particles are there forever and ever and ever. It's kind of cool because then you can add fields. Say particles, what is it? Fields, let's do Newton. And let me just put it over here. So now they're gonna suck themselves in. And you can do pretty cool things. Okay, so that's this type of particles, or emitter. The volume, like I said, is the same principles, it's just a little more expansive. This is the cube, so you can again change the you don't have a speed here. There's a speed random, there's no real speed. What there is away from center, and you got these arrows to help you. So if I do 0, then they're not, the particles are just being created within the volume. They're not trying to run away from the center unless I tell it to. Alright. You also have a long axis, so you can see the axis, and now the particles are going to run along that axis, around the axis. So now you can see that they're going to try and roll around the axis, sort of like a vortex. You have a random direction, so that's just going to randomize it, and a directional speed. Now the directional speed, if I set it to 1 or to 10, you're like, okay, yeah, 10, but in which direction? You see the direction right there. And you can either rotate this guy to, if you want to rotate the direction of it, or you can change. Let me just go back to undo a little bit. or you can change the speed, the direction, by changing the direction, 0 and 1, just like the directional. So you can see how it combines, starts combining. It's a little bit more advanced in that regard. And that's when that speed random also comes in, and the random direction. And let's give it a little bit of away from axis, and along axis, and around axis, and you can create some pretty nifty effects there. So this guy is not so complex, but then you have the sphere. The sphere, the volume sphere, has pretty much the same values, except it's got this guy called a volume sweep. And it's just making a sweep around the volume, so it doesn't have to be, it can just be like, you know, a 90-degree sweep with, I'll take the speed off so you can see the, or the away from center. Oops. And there you go. See, these particles are making it thunder outside. It's because I'm playing God. Alrighty, so cylinder, same thing, same values. So also you have a volume sweep. Cone, it's like a cone, and again you got pretty much the same attributes here: away from center, away from axis, all those little stuff. And torus is pretty much the same, except these guys, you can make them flow within the torus. So now they are created within that torus. And again, they have a rate, so if you want to have more particles, then you can totally do that. Then you have these surfaces. Now I kept these guys without any emissions because there's two types of ways, two different ways that you can make the emission for surfaces. I call this guy an omniplane, and I call these guys a plane. If I select an object and I go particles, I can tell it to emit from object, alright? But on the attributes, on the options, edit, reset settings, by default this is set to omni, and that's why I call that guy omni, because by default, if I hit apply, it's going to make an emitter, it's going to link the emitter there, but as you can see, it's sort of like putting an emitter wherever there's a vertex. Let's just go ahead and show the wireframe. So you can look at the connections there, and that's where those particles are being emitted. Now let's just go ahead and change the speed. Speed 0. And what I'm looking for here, minimum, maximum, there we go. So I'm going to give it a minimum of 0.1 and a maximum of 0.5. So as you can see, I'm just doing this so you can see it's actually creating a volume emitter wherever there's a vertex, alright? And it's following the basic principles of an omni emitter. If I were to change that to a directional, then it'll follow the same principles of a directional emitter, and if I do a volume, it'll do the same thing. So it's sort of like putting an emitter wherever there's one of those. But if I change it to a surface type, then it's a little different. It's actually emitting from the whole surface itself. Alright, so I'm just going to delete that for a second. I'm just going to hit here, apply as an omni, and hit here as a surface and apply. So you can see the difference. This is the omni and this is the surface. And as you can see, the surface is not like the omni type. This one is actually making the surface be a whole emitter, and it's based on the curvature. So if I were to put this guy's out like that, maybe this guy's out like that, then it's going to emit like that. Alright? So that's the main difference. That's why I kept those guys separate. Just go ahead and add these particles to the omni and add these particles to the surface. And the same principle applies with the curves. So here's this omni curve. So if I go particles, emit from object, option box. Again, reset settings, edit, reset settings, apply, and then this guy as a curve, create. So now, same principle. On one, it's doing it based on wherever there's a vertex, and on the other one, it's doing it all throughout the surface based on the tangency of the curve. Okay, so that pretty much takes care of that, and I'll see you in just a little bit with another tutorial for the shading and the types of shading and applying properties to particles.